Welcome to another video. Today I'm going to be showing you how to make some perfect top-down movement. So right now I've made this quick movement thing, and right now we have some basic movement. This guy can move, but we have a problem. Now we're going to fix today, and the problem is when you're moving diagonally, he is traveling over a longer distance than when he's moving to the left or right or up. So he's actually moving faster diagonally than to the left, right, and up, or up. So we want to fix that. We want to make some perfect top-down movement. So first of all, I've done some setting up. I have a speed and an acceleration variable already. I have the inputs, and this is like the code that I use so far to just do the movement. And then I just have an end step rounding the X position. But we don't want this. Like, this is, it works. And it might work fine for like platformers, but for top-down movement, does not work. So what we're gonna do instead, we're gonna create this script, and it can seem daunting, but I am gonna go ahead and we're gonna go through it like line by line and add it into this. So first of all, we need a velocity vector. This right here, let's just call it V because that's a lot faster, or VEL for velocity. This right here will be our velocity vector. So we're going to have this one, we're going to initialize it as an array. So as I've said before, this is a variable, and then we have the 0 in the X position and the 0 in the Y position. So the first value of this variable will be 0 and the second one 2. So we can use those as our code, like our vector calculations later on. And what we're actually also going to do is we're going to define some macros. So we're going to do macro X, and we're going to set that to 0, and then we're going to have a macro Y, and that's going to be 1. There we go. So then we can use these to access this vector, or this vector here. We have an acceleration. We also need a friction. Let's just set it to 0.5. Now let's do 0.1. So we slow down, like we slow down slower than we accelerate. So these are all the different variables you need. So you need some kind of input. You need a vector that monitors your X and Y velocity. You could also just do velocity X and set that equal to 0, and then do velocity Y and set that equal to 0. But I just like to have it in a vector like this, or in an array, because I feel like, to me, this seems nicer. It's all preference. I don't really think there's a huge performance issue or anything about it. So I'll go with the array here. So let's go ahead and go into the step event. And I'm just going to check we have the right, left. Yeah, we have everything that we need. So, first of all, let's get rid of this shit right here. First of all, we are going to do some stuff. We're going to initialize some variables. We're going to have a variable called direction X, a direction Y, and what's the last one? That's just a direction variable. There we go. And we're going to have a current speed. So these are the variables that we need. Now we have to set this will reset the directions. So dir X equals 0. So every time we go through this script or this code in the step event, the direction Y and X will always be set to 0 first of all. Then what we want to do is we want to have some checks for some movements, or some inputs here. So if we're pressing right or left, then we're gonna set the dir X to equal right minus left. So if right or left, so if we're pressing right or left, then depending on what we are pressing, then our direction X will then equal right minus left. So if we're pressing only left, direction X will be 0 minus 1, so that will be minus 1. And if we're pressing only right, it'll be 1 minus 0, which is 1. And if we're pressing none, it'll be 0. And if we're pressing both, it'll also be 0. So we're going to take that here, and then we're going to do the same for up and down. So if we're pressing up or down, then what we want to do, we want to have direction Y, set that equal to down minus up, because in Game Maker the coordinates are switched around. So instead of having up minus down, we want to have down minus up, and that does exactly the same thing. So if you are pressing up, the direction Y will be -1, and if you're pressing down, it'll be 1, and if you're pressing none, it'll be 0. If you're pressing both, it'll be 0. Next up, we need to calculate a direction, like the direction that the player is pressing. So we're going to have dir, and that's going to equal point direction, and it's going to point from 0, 0 to dir x and dir y. So what this does is, it's going to make a vector, and it's going to make the vector from point 0, 0, so x0, y0, to whatever direction x is, and direction y. So direction x can be 0, 1, or -1. So let's say that we are pressing right, then, and we're not pressing up or down, then this vector would go from point 0, 0 to 1, 0. So that means we'll have a vector pointing to the right, which will be this way for you guys. And if we're pressing, let's say we're pressing up at the same time, it'll go from 0, 0 to 1 and -1, which will be up to the right, like this. So that's basically what this is. This is giving us the direction that we're pressing. Next, we want to have the current speed. We want to measure the speed that we're going at. And the what we're going to do is, we're going to do this. We're going to have current speed. We're going to use this to make sure that we are not going faster than the max speed that we're set. So we're going to use point distance. And then what we're going to do is, we have x1, y1, and x2, y2. So we're going to go from 0 and 0 again. I forgot to add spaces between these guys, not too good. There we go. Just make the code a bit neater. There we go. So going from 0, 0 to our velocity at our x and our velocity at our y. Now remember, if you're using a script to do this, sometimes you need to put an @ sign when you're using arrays to use an accessor. So we'll just do it here because it's just a good practice to use that. So now we will measure the distance from, like, how far the vector is. That is our speed vector, our velocity vector, and then we can use that to see if it's over our speed. Then we can cap it so we won't go faster than our max speed. So now what we need the horizontal movement, and then we need the vertical movement. So first of all, we're going to check if right or left is pressed again. So if right or left are pressed, then we're going to check if the absolute value of our current speed is greater than or equal to speed. Then our x will plus equals length dir x with a length of speed and a direction of dir. Else our x will, no, this won't be plus equal, it'll just equal, sorry, and I'll go through this in a moment. Else we'll have length dir x, it'll plus equals our acceleration in the direction. So right now, what we are doing here is we're checking if we are moving, if we're pressing right or left, and let's say we are one of the two. First of all, it's going to check if our current speed, this variable here, so if our, like, the length of our movement vector, the velocity vector, if the length of that, meaning the speed, is longer than the speed variable that we set in here, which is 4. If it's longer than that, then x will then equal length the x speed and direction. And it should also actually be, no, I'm sorry, I'm using the wrong terms here. It should be velocity, sorry. So instead of using x, we'll set velocity add x to equal this, and down here too we're going to do velocity plus equals. Sorry guys, that was my bad. So if our velocity vector is longer than our speed in the x direction, then it'll be capped down to the speed, if that makes any sense. So if it's longer, it'll be capped down, it'll be set equal to whatever the speed is in the direction that we are pressing here, that we calculated up here. But if it's not bigger than the speed, then we're going to add our acceleration variable to it in whatever direction we are moving in. So it'll add 0.5 as long as we are below or equal, or below the speed limit. And then if we're not pressing any of these guys, then what we want to do is we want to have velocity at x and set it equal to lerp and do parentheses. We want a velocity at x. We want to go towards 0 with the friction amount. So what the lerp function does is it just takes a value, this value, and then it takes the value velocity x and then it moves it towards 0 by the amount that you put in here in the friction. So this would take whatever our velocity is, move it closer to 0 by a percentage amount, which will be 0.1, which is 10%. So if this were 100, then we would move 10 away from it, the first step, and then we would have a velocity of 90, and then again we would take 10% of that, which is 9, so then it would be 81, and so far, and that would go on until we hit 0, or at least as close to 0 as we won't move. So now we're going to take all of this code, we're going to do it again just for the up and down. So if we're pressing up or down, and I'm going to write it out with you because that's what you get the most, you'll get more, what is it called, get more familiar with the stuff by doing this, and you'll learn faster. So again, if the absolute of our current speed is bigger than our speed, we're going to use exact same check. Then our velocity, instead of the x, we're going to do the at y will equal length go y, and then we'll have the speed and the direction, else velocity at y plus equals length, I got length the y, and then do speed and acceleration and direction. And we need to put a space here because that looks neater. So I recommend like typing everything out instead of copying and pasting it if you're a beginner, because that really helps you in learning like the basics and remembering how to do stuff and the functions and stuff like that. If you just copy and paste it, you won't get the same value out of it. So here we're going to have our velocity. If we're not pressing these, then our velocity y will equals lerp velocity at y, and it'll go through 0 with the friction. There we go. So this should be all the movement code. Let's just check it really quick. Yep, that's all of it. And in the end step, we want to do x plus equals velocity at x, and y plus equals velocity at y. And let's run this and hope that it works. And I'm really sorry if you can hear the wind a lot because it's really windy outside. Okay, so we have a function here that's not... Oh, I spelled friction wrong. So in the lerp here, friction like that. Okay, cool. So that's it. When you write like longer pieces of code, you might have more bugs, but this seems to work, and we can move. As you can see, we don't move instantly. We like gradually build up speed, and we gradually slow down. And if we move to the right or to the left, or like diagonally, we won't move any faster than if we are moving to the left or the right. And we can actually prove this by drawing on the GUI, and then do draw text, and then do at 10, then we're going to draw a string of our velocity at x, and then we're just going to copy this, and at 30 we're going to do it with the y value. So right now we'll draw the x and the y on the GUI layer. So you can see right now they go up to 4 and stay at 4, but if we move diagonally they only go to 2.8. So it takes in account that we're moving diagonally, and if we are, then it limits it. So that's pretty neat. So now you have the perfect top-down movement. You can tweak these variables. You can set the acceleration to be a lot faster. If you set it equal to 4, then it'll be, or you can set it equal to speed to have instant acceleration. You can set it equal to half the speed. It'll take 2 steps to get up to full speed. Or you could say 10 steps for it. Let's do 60 steps. So this means it'll take a second for us to go from 0 to full speed. And the friction as well, you can also change that. If you want to do it stop immediately, you can set it to 1. Or if you want to stop it or start them immediately, what you could do would just be, instead of having all these checks here, you could just say velocity at y equals length y, and then speed and direction, and just get rid of all this acceleration stuff. And if you're not pressing it, you can just set it equal to 0 like this. So if you're not pressing it, then it'll just be 0. Means you won't move. But right now, as you can see, I just tweaked the speed variable, and as you can see, we started very slow and then we build up speed, and it takes a second for us to get to full speed. There we go. So that's pretty neat. You got a full and working movement system here, top-down perfect movement system. And again, if you have any questions, just ask me in the comments or write a message to me or whatever. It is fairly simple once you understand it. So I'll just go through it one more time. You can quit the video here if you want to. This is all I have, but I'm just going to go through it one more time, just line for line, so hopefully you'll get the full understanding of this down. So let's get to it. First of all, we get our inputs, right, left, up, and down. Then what we're doing is we're initializing our variables direction x and direction y, which will be used to checking what direction that our vector is pointing towards, that we will make from the keyboard inputs. Then we have the direction that we actually want to move in, and then we have the current speed, which is the length of our velocity vector. So every step of the game, first of all, we reset the direction x and y to 0, because if we set them, like if we do not reset them, they might stay at 1 or minus 0, or like 1 or minus 1, even though you have released the keyboard, and we don't want that. So then if we're pressing right or left, then our direction x will be equal to right minus left. So it can either be 1 or minus 1. And the same with up and down, can either be 1 or minus 1. Then we create a vector from 0, 0 to our direction x and direction y. So this could be a vector going to the right, to the left, up, down, diagonally in every direction. And that vector is used down here in the length x function to move it in our player. And I haven't actually explained the length x function, and I will really quickly once we get to it. The current speed will just take the distance from 0, 0 to our velocity x and velocity y, so the total, like the distance of our movement vector. Then right here we're checking again, are we moving right or left? And if we are, actually what we could do instead, instead of doing the checks again, we could just say if x does not equal 0, so if it's 1 or minus 1, so if x does not equal 0, that would actually also work. I'm pretty certain about that. So direction y does not equal 0, like that. That should work, and that, I think that'll be faster than calling these guys again. I'm certain it will. Then, so if we are moving to the left or right, then if our absolute current speed is bigger than or equal to speed, then we'll set the velocity equal to length x speed in a direction. So what this length x function really does is it takes the x component of a vector. So if you have a diagonal vector, let's say it's pointing like this, My finger is the vector here. So what the length x does is it takes the length from like the starting point, like here, the starting point, to the end point on the x-axis and get the length of that. So even though the whole length of the vector in this case will be 4, because we're moving diagonally, the x direction that we're moving it will only be 2.83 or something. So it'll take that information based on the speed that we put in. So it'll take a speed in and then a direction. So if the direction is diagonally this, and depending on the speed you put in, you'll get some, like, only the x component of the actual vector. So this here, if our direction were completely right, then, like, if the direction were only right, then our velocity x would be equal to 4 in the direct length of x. But if we were diagonally, it'll be 2.83, which is why when we move diagonally out, we move at the same speed than if we move to the left or right, because we also have the y value added onto that. And that, of course, if we aren't pressing, or if the speed is not the same as our max speed or above it, then we'll just add our acceleration using the length x again to our velocity x to make sure we accelerate with the same speed diagonally as we do to the left and right. And then otherwise, if we aren't pressing anything, then our velocity x will lerp, or will shrink towards 0 by the amount of friction, and the same will happen in the y direction. So once again, I'm just going to test this to check if the direction y does not equal 0 and that stuff works. As you can see, it still works even though you use those function. And I'm thinking this video's dragged on for long enough, so let's end it right here. I really hope you enjoyed it, and as I said, just comment if you need any help at all, and I really hope you enjoyed it, and I hope you can use it. Next up, I'll further build onto this, and we'll do some sub-pixel movement, and I'll get onto that in another video. But I hope you enjoyed this, and I'll see you next time. Goodbye.